Welcome to data mining. In this module, we will explore data mining and its context. I'm sure you've seen all the job ads for data analysts and data engineers on LinkedIn, Dice, Kaggle, and other forums, and you've read the articles on how data mining and analytics are one of the hottest fields to get into. So let's get started. In this module, you will learn what data mining actually is and what it is not, and what it does and what it does not do. You will also hear about the challenges that data miners face and that we'll be running into in this course. And you will have to start adjusting your expectations of how data mining should work in an organization versus how it really works. All right, let's dive in. So what is data mining and what is it not? The official definitions of data mining are the non-trivial extraction of implicit, previously unknown, and potentially useful patterns or knowledge from a lot of data, and exploration and analysis by automatic or semi-automatic means of large quantities of data in order to discover meaningful patterns. In other words, data mining and also data analytics really has to do with the discovery of patterns in a large set of data. This also means that looking up a phone number in a phone directory or just simply typing Amazon into a Google search is really not data mining. What is data mining, however, is to figure out that in certain American cities, certain ethnic names, like for example, Irish names in Boston are much more prevalent, or that the search output from a Google search returns information about the Amazon rainforest and about Amazon.com, and trying to group these search results into different classes. Now that is data mining. So why do we want to mine data? Well, number one, because we have data, and number two, because the amount of data that we produce and that we consume on a daily basis does never decrease, but it only increases. From the Fitbit or the health tracker that you have around your wrist as you exercise, to the network connected thermostat on your wall that allows you to use your cell phone to adjust the temperature in your bedroom to a cozy 70 degrees. And that data is not going to get any less, whether it's on the consumer market, as we have just seen, or whether it is in research, because ever more satellites and space exploration programs will deliver ever more data to Earth that we need to process. And biology and the Human Genome Projects and other genome projects that are currently ongoing will deliver more data about the nature, not just of the universe, but of the nature of ourselves and our surroundings. And we need to be able to make sense of this data. This is where a simple Excel spreadsheet just doesn't cut it anymore. And then lastly, we also have to consider what these data and the analysis really does, because data and the analysis really serves as material for decision makers to make better decisions, or to make decisions at all, about the planet, about military movements, about health campaigns, about vaccination campaigns, and all of those things that will help make human lives better on this planet. So the true goal of data mining really is to produce wisdom. This is also why it is called knowledge discovery in databases, sometimes KDD, or business intelligence. What we do in data mining is we take data from divergent sources that are formatted in all sorts of different ways. We pre-process that data in order to combine it and to make it analyzable, so that we have a large set of data that produces information, and then when analysis of patterns is applied, it produces knowledge. And that knowledge then can, when applied to decision-making processes, produce wisdom in decision-making. And that applies to all sorts of areas, from the military to doctors to city planners, salespeople, meteorologists, to even you. So data mining really does two things. Data mining describes and predicts. We describe data by finding human interpretable patterns inside those data. That's the story that the data that we currently have at our disposal tells us. We can do that by using techniques like clustering, like discovering associations among certain sets of data, certain sets of attributes, or also sequential patterns. But we use all of this in order to be able to predict how these patterns of data will change in the future and what future results they will produce. This is where we would use techniques like classification or regression or deviation detection, all of which we will discuss in this course. So here's another view of how data mining fits into the organization. Data analysts and data miners typically receive data from database administrators and others who procure the data from external and internal data sources such as operational systems and scientific experiments, then apply ETL tools to normalize this data and store it in a data warehouse. From there, data can be functionally separated into data marts, for example, logistics, marketing, whatever you're seeing in the lower left-hand side of the screen, in order to allow the data analysts to take this data, which has been normalized, and conduct data exploration. Data exploration usually happens with statistical analysis, hypothesis testing, and the like, in order to start finding potential patterns. This process continues in data mining, where models for learning and for information discovery are really developed. Now here we have another layer on top of this data mining, which is the business analysis layer that has to do with optimization, visualization of the data, and presentation of the analysis results, because we have to understand that the decision makers who make decisions, military, business, other organizational decisions on the basis of the analysis results, are usually not as conversant in the mathematical strategies that data miners apply to data as we would like. This is where a moment of translation has to occur from the mathematical language of data mining and data analysis into the business language of dashboards and spreadsheets as well. Let's focus for a moment on the discipline of data analytics and data mining. Data mining and data analytics really combines three different fields. The first one being statistics and artificial intelligence. The second one, machine learning and pattern recognition. And the third one being database systems and the traditional ways of extracting data from these database systems. However, due to the enormity of data that we have going on these days, these traditional techniques are becoming more and more unsuitable. We have many more attributes that we collect about entities in our world, and also the types of attributes and characteristics that we collect about entities in our world are becoming more and more heterogeneous and unstructured, rather than the structured data that we have traditionally kept in traditional database systems. With massive data sets come massive challenges as well. One of these challenges is scalability, because data sets are so big that traditional data processing just doesn't cut it anymore. That's also largely because of the high dimensionality of data. A data item these days does not come with dozens of attributes anymore, it comes with thousands of attributes. And these attributes are no longer nicely structured as we know them from traditional databases, but they are heterogeneous, meaning structured and unstructured, and it is our job to find dependencies and identify relationships among structured and unstructured data. And then lastly, there is a logistical issue that we may run into, which is really obtaining the data. We may have issues effectively consolidating our results, or also dealing with security issues around data, specifically personal identifying information and the like. And all of this leads us into, once we have aggregated our huge data set, we have made it ready for analysis, we need to figure out how to automate this analysis, because it is just not enough anymore to perform traditional, say, hypothesis testing, for example, but all our pattern searches have to be automated and programmed, and we have to also account for data to be, for example, biased and to be very specifically selected with certain intentions in mind. So these are only some of the challenges that we face when dealing with data sets, and especially with massive data sets. So each data mining or data analytics book will tell you that the data mining process works kind of like this. You establish your goals for learning, you have your databases, you have your algorithms in place, you know what you're dealing with, and then you get going. You develop a plan for your learning, you generate, you test your hypotheses, you discover your knowledge, you determine whether that knowledge that you've discovered is interesting and relevant, and then you are evolving your knowledge, you produce your analysis, you visualize your analysis, and then you present it. That is how the traditional data mining process should work. This is what you will be most likely reading about in the literature. And here's how the data mining process often works in real life. It starts with a question from a C-level executive. That question sends you into an enthusiastic pursuit of data that leads to aggregating a whole lot of data from a whole lot of different sources and really scratching your head about, how am I ever going to make sense of this? But you are. And then you're going to take all this data that you have aggregated and you're going to work it through a number of analysis engines, from simple spreadsheets to more complex engines, and you're going to do that not just once but a number of times, because every single time that you receive a result from one of these analytics engines, that will generate more questions that you will want to pursue. But at the end, you're going to have to produce a report, and that report will answer not just the initial question that the executive asked, but it will also maybe raise more questions or deliver more answers, because there are more answers that can arise from the first answer that you found. And you will have to present that report in a nice visualization and with a very well understandable format, because at the end, the decision maker has to be happy and understand your results. So in order to produce this information that leads to knowledge and then to wisdom in decision making, you have a whole arsenal of business intelligence tools and processes at your disposal. The first one being the advanced analytics, the predictive analytics, statistical modeling, the big data analytics, that then really translate into the second layer of a self-service business intelligence. This is where some C-level executives already come in, that has to do with online analytical processing, or OLAP, data discovery, and data visualization. This data visualization then often translates into the guided analysis and reporting layer as dashboards, as alerts in reports that allows performance management, spreadsheet integration for financial processing, for example, or also business intelligence searches that are then delivered into the cloud, into the intranet, on premise, or also via mobile applications. So let's look at what we have learned so far. We have defined what data mining is and isn't, and what it does and doesn't do. We have also looked at the challenges in data mining that can make the road from data to wisdom somewhat rocky at best and a long, hard slog at worst. Finally, we have seen that data mining in an organization isn't always the nicely structured process that we might expect it to be, but that the reality can be much more chaotic, especially when you're stuck having to integrate data from different sources in different formats and having to build numerous models to tease out the story that the data wants to tell you. Finally, though, the best math and the finest models are a waste of time if you don't spend the time beforehand to understand the data you're dealing with and the time afterwards to figure out what the results you're getting actually mean. That's why data mining isn't just about math, but it requires a healthy dose of critical thinking and interpretation. And that is often the hardest part about data mining.